part D. Find the average rate of change of f on the interval from x is greater than or equal, or -4 is less than or equal to x, which is less than or equal to 3. So really the interval that they've depicted right over here. And then they say there's no point C in that interval for which f prime of C is equal to the average rate of change. Explain why the statement does not contradict the mean value theorem. Fascinating. All right, let's do this first part first. The average rate of change of f on the interval. Sounds like a very fancy thing, but the average rate of change on the interval is really just the slope of the line that connects the endpoints of the interval. So this right over here, those are the endpoints, and let's figure out the slope of that line. So going from this point to that point, our change in x, we do this in a color that you're likely to see, our change in x over here, our change in x is equal to 7. And you could get that by taking 3 minus -4. You could literally just count 1, 2, 3, 4, 5, 6, 7. That's our change in x, and our change in y. When we run over 7, when we go 7 to the right, our change in y is equal to -2. We went from -1 to -3 is equal to -2. So slope, which is change in y over change in x, rise over run, is equal to 7 over -2. Or, the other way around. Change in y is -2 over 7. So -2 sevenths. And that's all it is. Now you could kind of think of it in kind of the more fancy sense, but you're going to get the exact same answer if you said, oh, well, look, the average rate of change of f on the interval. Well, the rate of change of f is f prime of x. That is the rate of change of f at any point x. And so if you want to find the average value of this over the interval, you would integrate it from our starting point from -4 to 3 dx, and then you would divide it by your change in x. So then you would divide it by, you would have it over 1 over 7. Over 1 over 7. But then this part right over here is just going to be the same thing as f of 3 minus f of 4. And then this over here, you have a 7 in the denominator. So this is really just your change in x. This is your change in x, which it was by definition, or how we actually set up this average right over here. And this over here is really just your change in y. So it really is just the slope between the endpoints. So we did the first part. Our average rate of change of f on the interval is -2 sevenths. And then let's think about the second part. They say there's no point C in that interval for which f prime of C is equal to the average rate of change. Explain why the statement does not contradict the mean value theorem. So the mean value theorem, just as a little bit of a review, it says that if we have some type of an interval, if you have an interval, so let me draw some axes right over here. If you have an interval, so let me draw an interval like this, and over that interval you have a differentiable function. You have a differentiable function, so maybe my function looks like this. It says there's at least one point C on that interval where the derivative at that point C is equal to the average rate of change. So the way I've drawn it right over here, the average rate of change of this function, I'll do it in magenta, is this right over here. And the mean value theorem says is that if this is differentiable, there's at least one point C in this interval where I have the same slope, where the tangent line has the same slope, where the derivative is the same as the slope, as that average slope. And you can see here, it's probably right over here, you have one of those points. And actually, we probably have multiple of them. We probably have another point right over here that's like that, and then another point there that's like that. And if you think about it, it's kind of intuitive that at some point, here we obviously have a larger slope, and over here we have a smaller slope, and since it's differentiable, our derivative is continuous. So at some point, the slope has to get to exactly what the average slope is. Now let's think about our little conundrum with this question right over here. Why is there not a point C for which f prime of C is equal to the average rate of change? And you can even verify that for yourself, because from -4 to 0, our slope is positive. We have a positive slope here, and then the slope just jumps down to -2. It just jumps down to -2, which is a much more negative slope than this. So it never gets to -2 sevenths. And the reason is that this is not a differentiable function at x is equal to 0. it is not differentiable at x equals 0. Our slope jumps here. And because it's not differentiable, the mean value theorem doesn't apply. Now you can imagine if this was differentiable, if this did have a continuous derivative, then you would find a point. So if this looks something like this instead, I'll continue it over here. If it looks something like this instead, where it had a continuous derivative, then there would be a point where the slope was the same as the average slope. Maybe it would have been right over there. So it's really because f is not differentiable over the entire interval. It does not have a continuous derivative. The derivative jumps from a positive value approaching 0 here, and it just jumps straight down to -2 right over here. It doesn't go continuously through all the values in between.